So in today's lesson, we're going to continue learning about trigonometry by investigating how to determine the length of a missing side. So yesterday we learned about the basics of trigonometry with right-angled triangles, and we learned about an acronym, I guess you'd call it an acronym, SOHCAHTOA. And hopefully our warm-up today also helped to remind you of some of the important details of SOHCAHTOA. So when we look at our sine, cosine, and tangent ratios, that SOHCAHTOA helps us to remind us which sides are involved in creating the appropriate ratio. So I have a triangle here, and this 37 degrees belongs in this angle right here. And so it looks to me as though in this particular example, I am looking to figure out what the value of x is. So x is presumably representing this side right here. And so some of the other information that I have, well, the only other piece of information that I have is that this angle right in here happens to be 37 degrees. And I know also that my this side right here is 11 centimeters. So what I would always encourage you to do is to first label all of these sides according to what we discussed previously: hypotenuse, opposite, and adjacent. So when I see this angle right here that's given, I'm going to use that angle in order to label my sides. Now, could I figure out this unknown angle? Absolutely, because I know that the sum of all the angles in a triangle is always ... 180 degrees. But why would I do more work than I need to? I'm not being asked for that angle, so I'm going to use the angle given to me in the problem. So I can see that I can start to label. Here being my right-angled angle in my triangle, I know that this 11 centimeters is my hypotenuse. I'm looking at the angle or the side opposite the given angle, and that forms my opposite side. And then this last side, which forms the other arm of my angle, is the adjacent side. Now, I quickly, I've labeled all my sides. Now I have to make a decision about whether I'm going to use sine, cosine, or tangent in this situation. So what I do is I will say, well, what do I have information about? Well, I have information about my hypotenuse, and I want to find out my opposite side. And it looks to me like the adjacent side really isn't involved at all in this. So I'm going to choose a trig function based on the fact that I have information, or I'm looking for information on the opposite and hypotenuse sides. So what of the three trig ratios involve both the opposite and the hypotenuse as part of the solution? Well, the answer to that is sine. Sine is opposite and hypotenuse. Cosine involves the adjacent side, and so does tan. Tan involves the adjacent side. And so neither of those are the most convenient ratios to use here. So let's begin. So now that I know that sine is involved, all right, the sine of my angle is 37. So the sine of 37 degrees is going to be equal to the length of the opposite side divided by the length of the hypotenuse. I'm going to carry on here. Sine of 37 degrees is equal to the length of my opposite. I'm calling that x. That is my unknown. And my hypotenuse has a length of 11. So there, I've set it up. So I've set this up so that I can solve for my unknown side, x. So now what I'm going to do is I'm just going to isolate x in this equation that I've set up by multiplying by 11, multiply by 11. So then I've isolated x. So x is now equal to 11 times the sine of 37 degrees. So now is where I'm going to stop and explain to you a couple of details related to using your calculator. So first of all, let me just pull up a calculator. Alright, so I've taken some snapshots of some of the most common calculators that I see students using. And so what you need to make sure, first of all, before we start trying to solve for these sides and using the sine, cos, and tan buttons, first of all, locate the sine, cos, and tan buttons. So if your calculator looks like this guy, there are your sine, cos, and tan buttons. Sine, cos, and tan again. And then over here, let me see. Sine, cos, and tan. There they are. So first of all, locate those. The second thing you need to do is you need to understand that there are 3 different modes when using trigonometry. And the mode that we start you with, because most students are familiar with degrees as a way to measure angles, is we use degree mode. So you need to make sure that your calculator is in degree mode. It's sort of like inches and centimeters. We can use different units to measure length, and we can use different units to measure angles. And one of the units we use most commonly and that is commonly understood is degrees. But there are also other units of measurement for angles other than degrees, and one of them is the radian. And so you can see that it's written in this title right here, degrees and radians. But we want your calculator to be in degree mode. And so you need to make sure that you are able to see that. So now usually it will appear in smaller letters somewhere on your screen, DEG. Sometimes it'll just say a D. But if you see this thing, I'm going to make this just a little bit bigger here so you can see it. But if you see this RAD in there, that means your calculator is in rad or radian mode and you need to change it. So another thing you might see is grad. So rad or grad is bad, degree is good for now. So one way that you will often be able to change it quickly on your calculator, you'll see a DRG button. So that stands for degree, radian, and gradient. So you need to make sure by, toggling through that you end up with DEG or a D symbol somewhere on your calculator screen. I'm going to make that smaller. Let's see if we can find it on the other calculators. Yes, it looks like there's a DRG button here on this type of calculator. I'm going to pull up the other calculator and see if I can find it. So I'm not immediately seeing that button here. My guess is that you'll have to look in a couple of different areas, likely the mode button. Mode will allow you to switch from degrees, radians, and gradients, but you should be able to see a little letter like somewhere on your screen to show you that it's been changed. I would try mode or even alpha, but probably mode. And if you are struggling with that, then reach out to me and I will try to help. So now let's get back to our solution. We've just about solved this, right? Now, another thing that I need to mention about calculators. Some of you will have what I would call a forward calculator. So forward, and some of you will have like a reverse calculator. And you'll only really know what if you try to punch in these values based on the answer that you get. So some of you will be able to, if you have a forward calculator, you'll be able to type into your calculator exactly what you have here. You might need to put in a multiplication symbol here, but 11 and then times and then sine and then 37. And then once you press equal, you'll get the value of x. I'm going to go ahead and do that and get an answer. So when I go ahead and type this into my calculator, the value that I'm getting for x, which by the way represents our side length, is 6.6. Now the instructions I'm going to be, are going to tell me how to round. It says the nearest tenth of a centimeter, so 6.6 centimeters. I've rounded to the nearest tenth here. So if the question indicates, then try to round to that value. Now, some of you, if you try to type that in the forward direction, then you will not end up with the correct answer, which is why it's really important for you to utilize your own calculator, a calculator you're comfortable with, specifically when working with trig questions, because every calculator is a little bit different. And so some of you, will have to, in fact, not type this in directly. You may have to go through the following motions. I'm just going to make this a little bit smaller so I can fit it in. Oops. You might actually have to type in instead the 37 first. So then 37, oops, and then sine. And then it'll give you a big ratio, and then times, and then 11, and then equals. So, you will know really quickly whether you have a forward or a reverse calculator because of the answer that you end up here. If you're using your cell phone works in reverse. So you'll have to type in your 37 first and then sine, and then the times, and then the 11, and then the equals. And you should get 6.6 centimeters. If you're struggling with that, though, let me know and we'll try to figure it out. All right, so here's a little exercise for you. What I'd like you to do is I'd like for you to try this triangle, and I'd like you to try to answer the question, which is to solve for the unknown side. So in this case, we're asked for side y. So give that a try on your own and see how you do by pausing the video and then resuming when you're ready. All right, so as always, I'm going to take a look at this. I'm going to label my sides. I see that I'm given the angle 42 degrees, which means that this would be my opposite side. My hypotenuse is always across from the right angle, so here is my hypotenuse. And it turns out that the only other side is my adjacent side, making the other arm of my 42-degree angle aside from the hypotenuse. So now I need to say, well, which of my three trig functions am I going to use? Well, that's based on the information that I'm given or that I'm looking to find. And so when I look at this, I can see, all right, well, I'm given information about my hypotenuse, so h is in, and I'm looking to find that other side, my adjacent side, y. So, it looks as though the opposite side isn't really involved in this situation, so I don't want to choose a trig ratio that involves the opposite side. So I'm going to rewrite SOHCAHTOA up here. SOHCAHTOA. And so I can't use any trig function that involves O, so that means that sine is out, and that means that tan is out. So the correct trig function to have chosen in this case would be the cosine function. So now I'm going to go ahead and I'm going to set up my solution. So the cosine of 42 degrees is equal to the length of my adjacent side divided by the length of my hypotenuse. I'm going to keep going. So the cosine of 42 degrees is equal to y, that's what I'm representing the adjacent side as, divided by 8.5. And so now I want to isolate this y by multiplying my 8.5. That will cancel it, but I need to balance that by multiplying the other side by 8.5. And so now I have my solution, and all I need to do is just substitute or plug this into my calculator, and I should be good to go. And so what I'm getting as my answer is 6.3 centimeters. So hopefully you did okay with that. And if not, you can let me know. All right, so let's try a couple of other questions and let's see how you do. All right, so let's take a look at this next question here. Same deal. I want you to go ahead and try to solve this question by going through the motions as we have before, by labeling the sides and then choosing the correct trig ratio, and then we'll take it up in a minute. All right, I'm going to go ahead and start to move forward with this. So I can see that here's the angle in question that I'm given. And so I'm going to find my opposite side, and then I can find my hypotenuse really easily, and then that leaves the last side as my adjacent side. And so looking at the information that's given to me in the problem, I can see that I have information about my opposite side, and I am looking for information about my adjacent side. So that means I need to choose a trig ratio that does not involve my hypotenuse. So again, writing out SOHCAHTOA. I want to choose a trig ratio that does not have h. So h is in sine, so that's out. H is in cosine, so that's out. So the appropriate trig function would be tan. So I'm going to go ahead and use that. So I know that the tan of 50 degrees is equal to my length of my opposite side divided by the length of my adjacent side. So the tangent of 50 degrees is equal to, my opposite side is 9 centimeters, and the symbol used for my adjacent side is lowercase a. Now, this is the case where, we haven't seen this yet. I'm wondering and hoping that you maneuvered this okay. Now, when my denominator is in the bottom, then that poses a different problem for me. So it means that I have a couple of different options, and one of them is to cross multiply. So remember that all whole numbers are really just fractions with a denominator of 1. And so if I'm comfortable with cross multiplying, I can simply cross multiply. And then that will move my unknown into the numerator. And so that will give me that, a times the tan of 50 degrees is equal to 9. And then I can simply isolate a by dividing by tan 50 on each side. Right? And that will eliminate that. And so now I have a situation where my unknown a is isolated. So a is equal to 9 divided by tan 50. Now, you may also remember that in class I talked about the whole upstairs downstairs principle when you're multiplying or dividing when isolating. Another way to think about this was, a is downstairs on this side, so I can move it upstairs on the other side of the equation. Tan is upstairs on this side of the equation, and I can move it away from my a once my a is up here by moving it downstairs on the other side. So there's my upstairs, downstairs. So now I'm ready to go ahead and type this into my calculator, and let's see what I get. So typing in 9 divided by, and you may have to go tan 50 if you have a forward calculator, or 9 divided by 50 tan, and then equals. And then that should give you your value. And I'm getting to the nearest tenth, 7.6 centimeters. Okay, one final example, and I'll send you off for the day with some practice questions. So here's the final example for you in trying to find side lengths using trigonometry. Okay, here is the solution. So here is my angle, 34 degrees. So that allows me to label. I've got my opposite side here, and I've got my hypotenuse across from the right angle, and that leaves my last side here as my adjacent side. So what do I have information on? Well, I have information on my opposite side, and I want to know about my hypotenuse. So looking at SOHCAHTOA, I'm hoping you were able to see, I'm just going to write this out. Which of the three involves my opposite and my hypotenuse? That is the sine function. So I'm going to go sine of 34 degrees is equal to the length of my opposite side divided by my hypotenuse, which is being represented by the unknown b. So now I'm going to use my upstairs, downstairs. I'm going to move b upstairs. I'm going to move my sine 34 downstairs. That will allow me to isolate b. b is equal to 15 divided by sine of 34 degrees. And so there I go. I'm going to substitute that in, and I'm going to look for my answer. Now, one thing I haven't mentioned, it should be 26.8 centimeters. I think. Now I'm going to pause to double check that. And that seems to be correct. Now, I forgot to mention this, and it's really good practice, I think, for you in any math problem is to make sure that your answer makes sense in the context of the question. So let me explain what I mean by this. So one way for me to sort of recognize right off the bat if I've made a mistake or not is, and it might not, it's just a good gauge, would be to say, well, B in this case is the length of my hypotenuse. And the hypotenuse really should be the longest side in a right-angled triangle. And so a good kind of quick way to gauge whether that answer makes sense is to say, well, what are the lengths of the other sides? Well, the other side I know is 15. And so, it should make sense, therefore, that any answer that I got that would be lower than 15 would be an answer that wouldn't make sense. So that's a way for me to say, okay, well, it seems reasonable to me that 26.8 could be the answer here. So anyway, so I will be giving you a worksheet to practice this skill. Please let me know if you're struggling at all. Reach out and we'll try to do some short screencasts to get you back on track. To the best of our ability, even a phone call might work, but please let me know.